Hi friends, welcome back. This is Dr. Sandeep, your mentor for this operating systems subject. We are into our third module and we are looking at the topic deadlock. So in the previous session we have seen what deadlock is and how deadlock can occur and all that, and we have seen that there are 4 conditions which all have to be met, only then there can occur a deadlock. Now let us see how we can handle deadlocks. So there are various way of handling the deadlocks, and let's see what they are. The first one is the deadlock prevention. Second one is the deadlock avoidance. Third one is deadlock recovery, and finally ignore deadlocks. So what they are, let's just get deeper information about each of these one after other. So to start, what's deadlock prevention? So deadlock prevention is one method where at least one of the Kaufman's conditions should be broken so that deadlock can never occur. As we discussed, so for deadlock to occur, there are 4 conditions called Kaufman conditions, and which have to satisfy simultaneously, only then there will be deadlock. Even if one of the conditions fails, definitely there is no chance of deadlock. So that is the main logic behind the deadlock prevention. So how to do that? So one option, no hold and wait. You may ask why we didn't use the first one. That is, the first one is mutual exclusion. Yes, we cannot avoid that, because to avoid the race condition we must have the mutual exclusion property, so that cannot be avoided. So no chance of thinking about it. Yes, let's start from the second one. Hold and wait was the condition. So just make sure that there is no hold and wait is possible. So what you can do is first identify what all resources are required. Before acquiring any resource, just identify all the resources required and request for all of them. And if we get all of them, then let us continue. If we don't get all of them, then let us not log, just leave them. So don't hold something and wait for something else. Either collect all the resources required or just don't collect anything at all. So that is how we can think of avoiding the second one, that is hold and wait. Next is preemption. Allow preemptions. So if you feel that for a longer period any resource is held by any process, and if you feel that that process is in wait state and all that, then better release that resource so that some other process may use it, and that way other processes continue to work, only one process gets cancelled. So you can just take away the resource from the process just by killing that process forcibly. So that way we can allow preemption, or make sure that there is no circular wait. So when you are seeing one is waiting for other is waiting for other, then you make sure that some way don't allow the circular wait. So as we discussed in the dining philosopher's problem, you fix up order of acquiring resources. You don't just allow everyone to pick from the left hand and then right hand. So you can think of the odd number person will pick left first, then right, and the even numbered persons pick right first, then left. So in this way what happens? we can ensure that this circular wait is cancelled. So that's other one. So in all, any one of these three, if you don't allow, then definitely deadlock will be prevented. So the advantage of working with deadlock prevention is simple logic. Definitely there will be no deadlocks, but yes, nothing comes free. There are some negative points on that, and this can reduce the resource utilization. Process concurrency may lead to starvation. Yes. What happens? So you are saying hold and wait. So then what you can say is you hold all of them, only then you allow. If all of them are not allowed, don't use them. So with that, what happens is the utilization of the resources may come down, and if all of them are not available at any given time, then a process will never be able to continue its job, so it can lead to starvation. So that's a negative point of prevention. So coming to the second one, that is the deadlock avoidance, and this will allow the resource allocation only if it doesn't lead to deadlock. So it's little more intelligent. Say that if some request has come for allocation, it just looks at the situation and overall what is what. And if it finds that allotting this particular resource to the requesting process, if it leads to deadlock, then that resource will not be allocated. So will be allocated only if there is no chance of deadlock. So that is avoiding the deadlock. How to do that? So there are algorithms like a banker's algorithm to ensure the system stays in a safe state. So before allotting the resources, and before identifying the sequence of the processes to which the resources are to be allocated and all that, there we have an algorithm, most commonly used, a banker's algorithm, and that's going to first verify the requests and then analyzes what could happen if we continue allocating the requests. Yeah, this whole thing is done without allocating anything. We just the background, we just analyze ourselves that these are the processors, these processors are requesting for these resources and we have so many resources and all that, and then if I keep on giving them, what would happen? If I keep giving in one order, what happens? If I give in another order, what happens? All these possibilities we just find out, work on that, and if we find that any one possibility, one sequence of allotment is safe, then we start allocating them in that particular order. So we identify the order in which the processes should be allocated the resources, and make sure that that way of allocation will not lead to deadlock. So this whole thing is analyzed before we begin allocation. So any given time, even on the way, we keep analyzing and see that things are in safe zone, and if we feel that things are in safe zone, only then we continue allocating the resources to the processes. So this require each process to declare the maximum resources it need well in advance. So before starting its work, it has to define what is the resources it requires and what is the maximum number of resources it requires and all that. So in advance we need to tell, each process has to tell what is required before starting its job. So advantage, more flexibility than the prevention, no deadlocks if algorithm is followed. Yeah, negative side, high overhead in tracking and calculation. So this algorithm is going to give a lot of overhead, and it's not practical if the future requests are unknown. So if we don't know in advance what resources we'll be requiring and how many we will be requiring, if we cannot tell in advance, then we can't use this algorithm, we can't avoid the deadlock through these ideas. So that's the problem. So if we have an idea that what all are required well in advance, then definitely we can avoid deadlocks. The third one, so no issue, can't prevent, can't avoid, okay, let it happen. So deadlock can happen. So if deadlock happens, so let us discover, detect whether deadlock happened, occurred, and if it occurs, let us recover it. So here we don't keep working in advance what could happen tomorrow, what could happen next day, and all that. Just we have we just be in a relaxed state till a deadlock occurs. When deadlock occurs, our system gets up and starts looking at the situation and detects what happened, why happened, and fixes them. How to do that? So there is an algorithm required for detecting the deadlock. That's similar to cycle detection in the graphs. So just as we discussed in the previous session, that the four conditions are satisfied, just keep watching. So have a allocation graph and just keep looking, is there a cyclic weight? So if there, yes, there is deadlock. So just a simple algorithm like cycle detection in the graphs, a similar algorithm to detect cyclic weight. So once we detect the deadlock, then abort one or more processes or preempt the resources. So there is a cycle, just one process aborted, then cycle is broken, definitely. So once the process is aborted, the resources it is holding automatically get released. Therefore they will be made available to other processes which we are waiting. So that may continue and will come out of the deadlock. If no, can think of more than one process to abort. Other side, let the process be working, let them preempt the resources. So instead of aborting the process, preempt a resource, release forcibly some resources and say currently let us leave this resource, and when the other resource which we were waiting for, when it is available, then we try to fetch this also or some way. So we recover the deadlock either by avoiding processes or preempting the resources. So the positive side of this is the maximum resource utilization is possible, and it is good for systems where deadlocks are rare. Yeah, every now and then if deadlock is occurring, then definitely it is not a good sign, because most of the time our system will be busy in recovering the deadlocks than doing the actual work. Therefore definitely this is not meant for a situation where frequent deadlocks occur. So this is the best remedy where deadlocks rarely occur. So the negative side of this is overhead of detection is more risk of data inconsistency, because we are just aborting some process, so it has done some work, and the data of that process will be in inconsistent state and it was aborted. So definitely there will be problems of data inconsistency. So when that process you have to roll back, then the previous state has to be recreated and then continue, or it will start everything from beginning. So whatever, this is going to be a risky, and recovery may be too expensive or maybe even not safe at all. So the next option, just ignore it. Assume that first thing is the deadlocks are rare, because with the current situation the availability of the processes processors, availability of the resources are so high that let's assume that the deadlocks are very very rare. Okay, then don't do anything, just neglect it. So then what? So this is used in many desktop operating systems like Windows or Linux. This is what happens. But what to do if there occurs a deadlock? So if deadlock happens, then it's a problem of the user. We will restart the process or the machine. So that's what we usually do. When we feel that nothing is moving further and find that something went wrong, our system went into some halt state, then we can't wait for any longer. Then we just have a habit of restarting the system or the process or the machine. So that's it. Don't have to do anything at all. So don't waste your time on creating some algorithms for your operating system or the kernel to worry about the deadlocks. So let the user worry about the deadlocks. That's a strict policy. This all is when it happens very rarely, and usually this happens with the user level processes, and if something goes wrong with user level processes, it is users responsibility to correct it and make them work again. So most of the time the desktop operating systems don't worry much about these deadlocks, so they just neglect it, ignore them. Yeah, that is possible only in simple user level operations, but when it comes to high level operations where security and all are important, then of course should make sure that no deadlock situation occurs. So that's a different type of problem we have. But in a common user level problems, neglecting the problem itself can be a better solution. So the advantage, it is very simple and practical for general purpose systems. Yes, definitely for general purpose systems it can be useful, but definitely not suitable for real time or critical systems where time is important. You cannot dare to face any sort of problem, any hold, any delay, nothing is tolerated that time. Can't ignore, you have to work out the other three possibilities. So that's it. Just an idea about how we can solve the deadlock problems. Just an overview of the deadlock problem solutions. Four solutions for the deadlock problem.